So for 12.2, guys, we are going to look at midpoints and bisectors. So we have a couple key terms that we're going to be looking at. The midpoint, we're going to look at a midpoint formula. We're going to define a segment bisector, and then we're going to be constructing segment bisectors. So that's what we're doing today. So let's look at problem 1. I will read it to you, but make sure you are reading along. So problem number 1. Mrs. Lopez, a kindergarten teacher, is planning a treasure hunt for her students. Isn't that nice of her? She drew a model of the playground on a coordinate plane as shown. So this is the playground. She used this model to decide where to place items for the treasure hunt and to determine how to write the treasure hunt instructions. Each grid square represents 1 square yard in the playground. So here's what I want you guys to do. Using this grid and then the information that you know about distances, I want you to determine the distance in yards between the merry-go-round and the slide. So do that right now with your groups or individually, but find the distance between the merry-go-round and the slide. Show your work. Okay, ladies and gentlemen, so to get from the merry-go-round to the slide, that would be this segment right here. Can somebody raise their hand and tell me how they found the distance? Brittany. You counted the lines. Did anybody else count the lines? How many of you use subtraction? Anybody? What would we be subtracting? Are the x coordinates the same or different? Different. Are the y coordinates the same or different? Same. So what would we be subtracting? The x coordinates. So what is the x coordinate of the merry-go-round? 11. So our distance would be 11 minus what? 3, which gave us 8. Okay, so that's what I mean by show your work. So if you counted the squares, make sure you write out the subtraction as well so that you can show your work using math. So how would we write this in a sentence?
The merry-go-round is 8 yards away from the slide.
Perfect. The merry-go-round is 8 yards away from the slide. Okay, something like that. It does not have to be word for word what I have, but the merry-go-round is 8 yards away from the slide. Okay, so let's read number 2 together. Mrs. Lopez wants to place a small pile of beads in the grass halfway between the merry-go-round and the slide. How far in yards should the beads be placed from the merry-go-round and the slide? And then I want you to write the coordinates for the location exactly halfway between the merry-go-round and the slide. If they are 8 yards apart, guys, how far away should she put the beads? 4. What? 4. 3.5 is not half of 8. How many yards? 4. So the beads, write that in a sentence for me. The beads should be... Four yards from the slide. If they're 4 yards from the slide, how far away would they be from the merry-go-round? Also 4. And 4 yards, make sure you include both. Okay, so here's what I have. The beads should be placed 4 yards from the slide and 4 yards from the merry-go-round. Let's graph that on here. So if I am 4 yards away from the slide, that's going to be 1, 2, 3, 4. And let's label it beads. So what are those coordinates? 7, 2. I ran out of room in number 2, so because there's nothing to write under number 3, I'm going to put the coordinates there. So the coordinates will be 7, comma 2. Is everybody okay with that? That they're at 7, 2? Because the y coordinates need to be the same, but the x coordinates need to be different? So let's look at number 4. How do the coordinates of the location of the beads compare to the coordinates of the location of the slide and the merry-go-round? I'm going to give you a sentence frame and I want you to fill it in for me, okay? So the y coordinates are what? And fill it in for a sec, and I'll let you fill it in. And then I also want you to tell me about the x coordinates. So the x coordinate is blank, then the merry-go-round, then the slide, sorry. Okay, so I want you to fill this in for me. The y coordinates are blank. The x coordinate is blank, then the slide, and blank, then the merry-go-round. So how does the x coordinate compare to the slide? How does the x coordinate compare to the merry-go-round? Fill those in for me. So what about the y coordinates? The y coordinates are what? 2 for everything. So they would be the same. So the y coordinates are the same. Okay, because the y coordinates of the slide, the beads, and the merry-go-round were all 2. What about the x coordinate? How did the x coordinate of the beads compare to the slide? For what? From the beads to the slide. What was the x coordinate of the slide? 3, 2. I'm going to write that down. So the coordinates of the slide were 3, 2. The coordinates of the beads were 7, 2. And the coordinate of the merry-go-round was 11, 2. Okay. So all of the y coordinates were the same. So how did the x coordinates compare from the beads to the slide? What was the x coordinate of the slide? What was the x coordinate of the beads? The x coordinate. Slide was 3 and the x coordinate of the beads was 7. So how do they compare? Add 4. So the x coordinate is 4 more than the slide. And what than the merry-go-round? 4 less. Thank you. 4 less than the merry-go-round. Okay? So turn your page. What I want you guys to do is with your groups now. I'm not going to do this one with you. Do numbers 5 and 6. So read 5 in your groups and answer the question. I already set up how I want your work to be shown, and so you're going to have to fill in blanks. And then answer number 6 for me. Okay, guys, how did you find the distance between the swings and the slide? The sides count the boxes. Subtract what? What did you subtract? The x coordinates or the y coordinates? The y's, because the swings and the slide are right on top of each other, right? So the x coordinates are the same, so let's subtract the y. So what did you subtract for swings and the slide? 12 minus 2. And that came out to 10 yards. So they are 10 yards apart, right? So then if she wants the kazoos to be halfway between the slide and the swings, what would the distance be between the kazoos and the slide? 5 yards. It's just halfway, right? So how many of you graphed that on your graph? Okay, so if we are 5 yards in between, let's graph it. So that means I'm going to go up 1, 2, 3, 4, 5. Let's label it kazoos. What are the coordinates of that point? 3, 5? 3, 7. So the coordinates are going to be 3, 7. Okay. Filling out this for number 6 should have been a little bit easier. So how do the coordinates of the location of the kazoos compare to the coordinates of the location of the slide and swings? The x coordinates are what? The same. Okay. The y coordinate of the kazoo is blank than the slide. 5 more. And blank than the swings. 5 less. Okay. Questions, comments, or concerns about those? Okay. So let's look at number 7 then, and we're going to get a little bit trickier. So can somebody read number 7 to all of us? Tom, will you read for us?
This process was place a pile of lessons in the gap halfway between the swings and the merry-go-round. Describe how you can determine the halfway point between the two locations.
Thank you. Okay, so the swings and the merry-go-round are diagonal like this. I'm going to try my best to draw a straight line. Okay, can we just count the number of spaces? Can we just subtract the x coordinates or just subtract the y coordinates? No, so what ideas do you guys have? Distance formula. Can you guys write that? So how does the distance formula help us? That gives us the distance between the swings and the merry-go-round. And then what would we need to do? We're looking for halfway, so after we find the distance, we would want to divide by 2. So will you guys write that right here in number 7? Something in your own words. Okay, I wrote something like this. I can use the distance formula to find the distance between the swings and the merry-go-round and then take half. Yours should have been something like that in your own words. Okay? So let's look at number 8 then. How far in yards from the swings and the merry-go-round will the pile of buttons be? And then we want to plot that location on the coordinate plane, and it says to round our answer to the nearest tenth, which is 1 decimal place if necessary. So we need to use the distance formula first, and then we need to divide by 2. So let's let D equal the distance between the swings and the merry-go-round. So you always have to define your variables. And then I'm just going to write out the distance formula for you guys first. So D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. We get the distance formula from what theorem? Pythagorean theorem. It's exactly the Pythagorean theorem. So here's what I want you guys to do right now. You can do this individually if you want, or you can work with your groups. Talking is okay. Find, using the distance formula, the distance between the swings and the merry-go-round. So you're going to need to find the points of each of those. And I wrote out the distance formula for you, so complete the distance formula for me. Okay, guys, let's finish this together. What did you plug in for x2? Okay, I'm hearing 2 different numbers, 11 or 12. Which one is the x coordinate? What are the coordinates of the merry-go-round? 11, 2. And what are the coordinates of the swings? 312 or 412? 312. So we're looking at the x coordinates first. So which x coordinate did you put first? 11 minus what? 3 squared. Plus, now the y coordinates. So because we used 11 first, we have to put 2 first minus 12 squared. Okay, guys, so that's D equals, what's 11 minus 3 give you? 8. Oh. me move all this over. So that gives you 8 squared plus, what's 12 minus 2 give you? Negative 10 squared. Okay, so when we square all of this, that gives me 8 squared. 64 plus 100. So I'm looking for the square root of 165, or 4. Whoa, I don't know where I got 165. Square root of 164. Is that a perfect square? No. Who was able to do the calculation for us? Approximately what? 12.8. So what is this saying? The distance between the swings and the merry-go-round are approximately 12.8. So how would I find the distance that I want to put the, what are we putting out? Buttons. How would I find the distance of the buttons then? Divide by 2. So the distance between the buttons, so let's say buttons equals 12.8 divided by 2, which should give us what? 6.4 yards. Okay? So that's all they want us to do. So 6.4 yards. So where would halfway between the swings and the merry-go-round be? 7.7. How'd you know that, Dana?
Well, it's just like
It is in the middle. So this would be the buttons. And they are 6.4 yards apart from each one. So the buttons would be right here. Another way we could have figured that out is we realized that the midway point between the slide and the merry-go-round was at 7.3, and the midway between the slide and the swings was at 3.7. So midway between both would be 7.7. Okay. Oh, super smart, huh? Okay. So we are going to need to use this then in order to develop a formula for the midpoint. Because like we saw in this problem, it's not always going to be, the distance is not always going to be nice and straight along the edges. We might have to do a diagonal distance. And I guarantee that it's not every single time going to work out to be 7.7 right in the middle. So let's skip page 670, and we're going to go to page 671. Okay. So we are going to derive the distance or the midpoint formula ourselves. Okay, so let's look at number 10. Use the diagram to describe these distances. By the diagram, it means this diagram right here on 670. So we're going to be flipping back and forth just a little bit. Now this time, they put the swings and the merry-go-round in different locations. And so instead of giving you the actual points, they generalized this. We did this when we were doing the distance formula, right? So because we don't know the actual locations of all of these, we generalize them in terms of x's and y's. So we called the slide x1, y1. And we called the merry-go-round, it's in a different x location, but the y location is the same. So we call it x2, y1, because they're on the same y location. The swings, we call x1, y2, because the x's are the same, but the y is in a different place. So we're going to use these generalizations to then derive the midpoint formula, okay? So number 10, this is nice because it takes us step by step. We want the vertical distance from the x-axis to the slide. Vertical means up and down or side to side? Up and down. So the vertical distance, and I'll flip back. You guys can keep your number 10 up. The vertical distance from the x-axis to the slide. So if I'm going from the x-axis to the slide, what was that y-coordinate? From the x-axis to the slide. That's your y-coordinate. What is it? y1. So we're going to call it y1. Okay. So then it wants to know the distance from the slide to the swings. So if I wanted to find the distance from the slide to the swings, what would I subtract? y2 minus y1. Why would I not subtract the x's? Because they're the same. So we're going to subtract the y's, y2 minus y1. So that's what we're going to do next. So y2 minus y1. Okay. Part C says half the distance from the slide to the swing. So that would be y2 minus y1 divided by 2. And then let's see what it says. Then we take the vertical distance from the x-axis to the slide plus half the distance from the slide to the swing. We've already done the vertical distance from the x-axis to the slide. What was that? y1, right? It means this distance right here. From the x-axis to the, what did it say, to the slide? The x-axis to the slide. So that's this distance right here. Okay, so it wants us to take y1, the vertical distance, plus half the distance from the slide to the swings. That's this guy right here. y2 minus y1 divided by 2. Okay, this is y1. Sorry. So basically what we're doing here is we are taking the distance between these two and we're dividing it by 2, and that gives you the halfway point. However, finding the halfway point right here does not give me the actual coordinate y. Any ideas? If I were just to find the distance between these two and then divide by 2, why does it not give me the actual coordinate of the midway point? Because I don't have the numbers, and is the slide directly on the x-axis? So that's why we have to add the distance between, because even if this midway point comes out to 5, I would have to add 5 to whatever this distance is. Does that make sense? Because this we don't have the numbers for. So that's why we're adding. So then number 11 says it wants us to simplify the expression from part D right here. So that means we want to try and get all of it together. So can I add y1 plus this thing right now? Why not? They don't have what? Well, we can do it without numbers. That's like terms. Why can I not combine like terms here? Well, we have a y1 and a y1 right here, so those are like terms. This one's divided by 2, so they don't have a common denominator. What's the denominator of y1? A 1. So in part 11, rewrite that whole part from number 10, divide it by 1. What would the common denominator be? Okay, so how could I get y1 over 1 to have a denominator of 2? Multiply by 2. So multiply the top and bottom by 2. So that's going to give me 2 times y1 is 2y1 over 2 plus y2 minus y1 over 2. Equals. What can I do with the numerators after I have everything on a common denominator? We can put them together, right? So this is 2y1 plus y2 minus y1 all over 2. So I just put all of them over the common denominator. And then, can I combine like terms? Are there any like terms here? The y1. It's the same y1. That's why we put numbers next to them. So what would 2y1 minus y1 give me? y1, positive y1. So this would be y1 plus y2 all over 2. So this would be finding the midpoint in terms of the y-coordinate. So what I want you guys to try right now, and you probably need to work with the people in your group, so I should hear a little bit of talking. You are going to do this exact same process, and I'm going to leave it up on the board for you, but this time you're going to do it with the x-coordinates. Okay, so horizontal distance, meaning the x-coordinate. It follows the exact same process, but I want you guys to try it on your own, okay? So you can work with the people in your groups. I would probably suggest it. Make sure you are reading what the question is asking, but you're doing the exact same thing with the x-coordinate. So try it out right now for yourself. Okay, guys, what is the horizontal, meaning side to side, distance from the y-axis to the slide? x1. That should make sense because the y-axis is right here, and the distance from the y-axis to the slide is what's given by the x-coordinate, okay? So that's the distance from there. So then, what would be the distance from the slide to the merry-go-round? x2 minus x1, so we're subtracting the x-coordinates. And then to take half of that, we would take x2 minus x1 and divide by 2, so that should have been the easy part. And so then we want to put those parts together. The horizontal distance from the y-axis to the slide plus half the distance from the slide to the merry-go-round should have come out to x1 plus x2 minus x1 divided by 2. And then to simplify, here is my work. So we had to put x1 over 1 and then multiply by 2 so that we have common denominators. So now I have 2x1 over 2 plus x2 minus x1 over 2 equals, and then I put all the numerators together, and when I combined my terms, I ended up with x1 plus x2 over 2. Yes? Okay, this is the midpoint formula. You just derived it yourselves. Now we're just going to be able to use it. So turn the page, and you're going to need to get out your highlighter. Here is the midpoint formula. Okay, let's read this together. The coordinates of the points you determined are what are called midpoints, or points that are exactly halfway between two given points. So the midpoints are exactly halfway. The calculations we perform can be summarized in the midpoint formula. So the midpoint formula gives us the coordinates of the midpoint. So all I need you to do is highlight midpoint formula and then highlight the actual formula. It is not technically really a formula per se in that you put equals and then we get an equation. It actually is in big parentheses separated by a comma, which means that they are coordinates. So to find the midpoint x-coordinate, we take x1 plus x2 and divide by 2. And to find the midpoint y-coordinate, we do the same thing but with the y-coordinates. y1 plus y2 divided by 2. Okay? So I'm going to do number 14 with you guys, and then you're going to work on some of this on your own. So, using the midpoint formula, let's determine the midpoint between the swings and the merry-go-round from question 7. So we hypothesized that the coordinate was going to be 7, 7. Okay, that's this part right here, where we put the buttons in between the swings and the merry-go-round. Okay, so it looked like it was at about 7, 7. So let's use the midpoint formula to see if the coordinates actually come out to that, okay? So I'm going to write down the coordinates so that we can use them. So the coordinates of the swings was what, guys? What was it? 3, 12. And what about the merry-go-round? 11, 2. Okay, and the merry-go-round was 11, 2. Okay, so let's use the midpoint formula here to determine if the answer actually comes out to 7, 7. So to set this whole thing up, I make one big parenthesis. And then the midpoint formula says that I use x1 plus x2. So I'm adding the x's this time. So 3 plus 11. All over 2, comma, because that was my x-coordinates, so now I need to work with the y-coordinates. So the y-coordinates are y1 plus y2, so that's going to be 12 plus 2 divided by 2, and then close off the big parentheses. All right, ladies and gentlemen, you all have been really, really quiet, so help me out here. What's 3 plus 11? 14 divided by 2, comma, 12 plus 2. 14 divided by 2. So this is how I want you showing your work. So you're going to plug everything into the midpoint formula, and then you're going to simplify, and then we're going to actually divide them by 2. 14 divided by 2 gives me 7, and then 14 divided by 2? 7. So the coordinate actually came out to be 7, 7. Is that what we guessed? Yes, that's what Dana said, that it looked exactly in the middle, and it ended up being exactly in the middle. Okay? So, let's look at number 15, and we're not going to write down an answer, but let's talk about it really quick. Do you think it matters which point you identify as x1, y1, and which point you identify as x2, y2? So does the order that we plug them in matter in the midpoint formula? Yeah, so we switched this to saying 11 plus 3 or 2 plus 12. Would that have made a difference in my answer? How come? Because we're adding. So the order that you plug the x's and the y's in actually doesn't matter. You just have to make sure you plug the x's into the x and the y's into the y. Okay? So here's what I'm going to have you guys do. There are 4 problems here in number 16, A, B, C, and D. I want you working on these. We're going to check our answers. You can work with the people in your groups. If you want to do it individually, you can do it individually. But I'm going to give you, how much time do you guys think you need? 5? 5 minutes, and then we'll check our answers in 5 minutes. So do parts A, B, C, and D for me. Okay, so we wanted to determine the midpoint of each of these, with these given endpoints. So for part A, let's see. Clea, what did you plug in for the first part in part A? 0 plus 4 divided by 2, good. Michaela, what did you put for the next part? 5 plus 3 divided by 2. Thumbs up if that's what you guys got, if you agree. Any thumbs down, disagree. Okay. All right, everybody, what's 0 plus 4? 4. And 5 plus 3? 8. So the next step, you should have written 4 divided by 2, comma, 8 divided by 2. So what would the midpoint be for part A? 2, 4. How many of you, just raise your hand, not your mouth, remember to put it in parentheses separated by a comma? If you did not remember to do that, make sure you do so now. The midpoint formula gives you the coordinates of the midpoint. So we could graph these 2 endpoints, and then we could use the coordinate 2, 4 to graph the midpoint. That's what we're doing. Okay, good. Part B, Samantha, what did you plug into the first part? 8 plus 6 divided by 2, good. And B, what did you plug into the second part?
2 plus 0.
2 plus 0 divided by 2. Okay, everybody, 8 plus 6 gives me 14 over 2, and 2 plus 0? 2 over 2. So what is my midpoint here? 7, 1. Thumbs up if you agree. Thumbs down if you disagree. Fabulous. Okay, part C. Emily, what did you plug in for the first part? Negative 3 plus 9 over 2. And Tatiana, what did you plug in for the second part? 1 plus negative 7 over 2. Good. Okay, make sure that you're putting the negative 7 in parentheses, guys. Okay? So here's the tricky part, because I know some of us are still struggling with adding positive and negative, so let's make sure we all got the same thing. What would negative 3 plus 9 give you? 6 over 2. Comma. Okay, what about 1 plus negative 7? Negative 6 over 2. How many of you got negative 6 over 2? You agree? Good. Okay, 6 divided by 2 gives me 3, comma, negative 3. Good. Okay, so far so good. Last one. Asia, what did you get for the first part? Negative 10 minus 4? Good. How many of you put negative 10 plus negative 4? Are they the same thing as negative 10 minus 4? Yeah, it's the same thing. So you can put either one. It does not matter to me. Divided by 2, comma. Anthony, what did you put for the next part? Negative 7 plus 7 divided by 2. Is it okay that he switched the order? Yeah. Why? Because we're adding, so the order doesn't matter. So, negative 10 minus 4, guys, what does that give you? Negative 14 divided by 2. Okay, what's negative 7 plus 7? 0. Okay, so what do my coordinates end up being here? Negative 7, 0. Excellent. How many of you got all 4 of those correct? Perfect. Okay, any questions, comments, or concerns about this? Midpoint formula, 0 to 5, how do you feel? 5 is the highest, 0 is I still totally don't get it. Show me with your hands. 5, 4, fabulous. 4.5. Okay, cool. So let's now look at using the midpoint formula in a different way. So let's look at problem number 2. What I want you guys to do right now with your group, so I do want you working together, elect one person to read the problem about Jack and his spare key to the group, and then just do part 1 where it wants you to plot and label the location of the back door and the oak tree. Okay? Okay, so we have Jack, and he was not a smart boy. He buried his spare key in the backyard in case he ever locked himself out. And then guess what? He locked himself out, and he also lost the keys. So, but he remembered that he buried the key 1/4 of the way between the back door and the oak tree. And the location of the back door and the oak tree are at 2-3 and 12-3 respectively. So, you should have read the problem and graphed the back door and the oak tree. It looks like we are counting by what? 1's on the x-axis, and what about the y-axis? Well, it's 1's, but how many spaces are in between each one? 4. So we're counting by quarters, okay? So make sure that you should have been paying attention to that. So if the back door is at 2-3, on my x-axis I'm counting by 1, so I'm going to go over 2. And the y-axis I'm going to go all the way up to 3. So that's going to be right here. And then you should have labeled it back door. Okay. And then the oak tree is at 12-3. That's really nice because it's already labeled for me. And so then I'm going to go up to 3. So the oak tree should have been right here, and I'm going to label that oak tree. So far, so good? If you did not graph correctly, make sure you fix that right now. And then let's determine the location of the key. So part A, we are going to be thinking about a way that we can approach this problem. Okay, so how would you determine the coordinates of the location of the key if it is 1/4 of the way from the back door to the oak tree? Discuss it with your group. So I want to hear academic discussion right now. Okay, which group has a suggestion for us? Brittany, what does your group suggest?
To find halfway and then find half of that.
To find halfway between the back door and the oak tree, and then find half of that. What other groups came up with that solution?
We did.
Anybody come up with something different? Okay, why does half of the half work? What's half of the half? 1/4. So that's how we're going to find it. So let's write that in part A, but let's use academic language. So please do not put, I would find half of the half. What is halfway between the back door and the oak tree called? The midpoint. We would find the midpoint between the back door and the oak tree, and then we would find the midpoint again. So write that here in part A for me. If you want to add some nice vocabulary in there after you've read mine, that's okay, but It needs to be in your own words. So here's what I said. I would find the midpoint of the segment between the back door and the oak tree, and then I would find the midpoint between the back door and the first midpoint. Your explanation did not have to be exactly like that, but it should have been something similar, right? You found the midpoint of the midpoint? Okay? So here's what I want you guys to do. With your groups, what I want you to do for part B is I want you to draw a line about halfway down the page, or halfway between the page. Okay? Label the left-hand side midpoint, back door, and oak tree. Okay, so I want you to label that the midpoint of the back door and the oak tree. And then I want you to label the right-hand side, do you want to say midpoint of the midpoint in back door, or do you want to say, or key, location of the key? How about that? Let's just call it the location of the key. Okay, so you guys determined, because you talked about it in your groups, that first we would need to find the midpoint of the back door and the oak tree. Then we would need to find the midpoint of that. So I already set it up for you. On the left-hand side, find the midpoint of the back door and the oak tree for me. On the right-hand side, use that to find the location of the key. So go ahead and go. And then I want you to write your answer in a sentence. So with your groups or individually, work on that right now. Okay. How did you determine the midpoint of the back door and the oak tree, Andrew?
Wait, so what you did? Okay, what was the question?
How did you determine the midpoint between the back door and the oak tree?
Oh, I did the midpoint formula.
Okay, so you did the midpoint formula. What did you plug into the first part?
2 plus 12.
2 plus 12.
Divided by 2.
Okay, and then the y's would be?
3 plus 3 divided by 2.
Okay. Ladies and gentlemen, do you agree?
Yes.
Yes. Does anybody disagree? Okay, so what would be 12 plus 2? 14 over 2. And 3 plus 3 gives me? 6 over 2. So what is the midpoint between the back door and the oak tree? 7, 3. Can we graph that?
Yes.
Okay, so on the graph, let's graph that. So 7, 3 would be 1 less than 8, and then we would go all the way up to 3, right? So let's graph that. And then let's label the point 7, 3. I know I didn't tell you to do this, but let's do it. Okay. Okay, then how would we determine the location of the key after we have determined the midpoint between the oak tree and the back door? Jordan, do it again, but using 7.3. So Jordan, how did you guys plug it in? 7 plus 2 divided by 2. Tom, I know that the 7 came from here. Where did the 2 come from? The back door. It's between the midpoint and the back door, so we have to use the back door coordinates again. So we have 7 plus 2 over 2, and then what did you guys put for the y? 3 plus 3 over 2. Okay, so that gives me 9 over 2, comma, 6 over 2. So the key is located at 4.5? Comma 3. How many of you put 9 over 2 instead of left it as 9 over 2? Anybody? You can do that as well. So you can leave it as 9 over 2, comma 3, or you can leave it as 4.5, comma 3. Most of you did 4.5, so let's do 4.5. So the key is located at the point 4.5, comma 3. So let's graph that. Where would 4.5 be? in between 4 and 5. So, and then we're going to go all the way up to 3. So it should be right here. And then label that 4.5, comma, 3. So did Jack find his key? I think so. Finally, right? Okay, because all of you guys are chicken about reading out loud, I'm going to do it. So, in the previous problem, the problem we just did with Jack and his keys and also with the kindergarten teacher, we located the midpoint of a line segment on the coordinate plane. The lengths of these line segments are measurable, right? Because they're on a coordinate plane, we can measure how long they are. So we're going to do some problems where you cannot measure the midpoint of the line segment. So in this problem, we will locate the midpoint of a line segment when measurement is not possible. The basic geometric construction used to locate a midpoint of a line segment is called bisecting a line segment. So I want you to highlight that. When bisecting a line segment, you create a segment bisector. A segment bisector is a line segment, or array that divides a line segment into two line segments of equal measure, or two congruent line segments. This term should be familiar because we've already talked about segment bisectors, right? Just as with duplicating a line segment, there are a number of methods to bisect a line segment. So we looked at duplicating a line segment, and we had two ways of doing that. You could draw a circle and make the circle and do different radii to the circle, or you could just make a little arc. Remember, we decided both methods were the same. One method is to use tracing paper, which is sometimes known as patty paper. So that's what we're going to do right now. Tracing paper. I'm going to give each of you a piece of tracing paper, and we are going to follow the instructions to draw a line segment, okay? I'm going to describe to you the instructions. The instructions are all written in your packet as well, so you can use those if you ever need to. So let me put this under here. So here's my patty paper. The first thing we are going to do is we are going to get to draw your own line segment. So whatever line segment you want. Okay, so I'm going to draw my line segment, and I'm not going to make it go through the exact middle of the paper so that you guys can see what we're doing. So I'm just going to use this as my straight edge, and let's have it go this way. You can make your line segment however you want, as long or as short as you want. Okay, that's my line segment, so you're not doing this yet. To bisect it, so we want to find the midpoint, and we want to find the point exactly where we can cut this segment in two equal parts. So you are going to take your paper, and you are going to fold it so that the end points lie on top of each other. So you are not necessarily going to fold it in half. I want my two end points to lie on top of each other. So mine is going to actually go kind of diagonal. And the reason we use this paper is because you can see through it. So you're going to line up the two segments so that they're on top of each other. And then fold your paper. And guess what? I just folded it in half. So my line segment, I folded exactly in half. So where the crease and my line segment intersect, that is my bisector. And I'm going to call that my midpoint, which is, usually we use M to locate the midpoint. Okay? And that is duplicating or bisecting my own line segment. So what I want you guys to do right now is do your own on your patty papers. So using the patty paper is just one way to find the midpoint of the segment, but how realistic is it that we're able to do this every single time? Not really, because I'm not going to buy millions and millions of pieces of this paper for you guys. So we can also use geometric construction tools to construct bisectors. So turn the page over for me. So that's why you guys have your compass. So the instructions are all written out for us. I'll read them to you, but it's already right here for you. So to construct a midpoint or a midpoint bisector of a segment, the first thing you are going to do is you are going to open the radius of your compass to more than half the length of your segment. Okay, so I'm going to open my compass to more than half the length of my segment, and then I'm going to draw an arc going through my segment. Then we're going to construct another arc using the other endpoint, but you need to make sure that the radius of your arc is exactly the same. So without moving your compass, you're going to construct a second arc using the other endpoint, and they have a little picture for you. And then we're going to construct a line by connecting the two places where the arcs intersect, and that is your midpoint. Okay, so the line that goes through those two intersection points is your midpoint of your segment. So let's try it. Okay, so turn the page for me now. So those are your instructions. Okay, so we're going to skip number 3 and let's do number 4 together, and then I'm going to have you guys do B and C. So let's construct the midpoint bisector of segment AB in part A. So everybody should have a compass now, right?
Yes.
Okay, so let's set our compass on point A. Open it so that it's somewhere greater than halfway. So it can be like almost all the way to B. It can be really close to halfway. I usually go somewhere in between, but it needs to be greater than halfway. It doesn't matter, because we just need it to be bigger than half so that our two arcs will intersect. So now draw an arc going through. Please be careful with these because these compasses are kind of loose. So what I have found is if you keep it really tight on the end point and then just twist it with your fingers is the best. Okay, make sure you make your arc nice and big because we do need them to intersect. So try and go like about half a circle, okay? Now, without changing the opening of your compass, put the end point, or put the tip of your compass on endpoint B, and you're going to do the exact same thing. So that's why it has to be greater than half, because if our compass was open only halfway, they would never intersect. So we want them to intersect. The bigger you open your compass, the higher up the intersection points are going to be. So if you go all the way to B almost, your endpoints would probably be all the way up here. So you should have two arcs now that intersect. So what I want you to do is draw the points where they intersect. They did want us to label them. Did they ask us to label them? Yeah, what do you guys want to label these 2 points? C and D? Okay. So C and D. And then you're going to use your straight edge, so you can use the side of your paper, side of your binder, something like that, or if you have a straight edge, you can use that. And then we are going to draw a line through those 2 points of intersection. Since this is a line, guys, what do I have to have on the end point? Arrows. And let's label our midpoint. So where the line and our segment intersect, that is your midpoint. Okay? So try that with B and C now. So here are the other 2. So your arcs, like I said, as long as they're bigger than halfway, you are fine. Always label the midpoint M. It really doesn't matter what you label these guys, just as long as you don't use M or the endpoints that are already used. Okay? So that is midpoint formula, and then we constructed midpoints using our compass and a straight edge. You guys can take my compasses home, but remember, you are just borrowing them, so please take good care of them and return them. Bring them back to class tomorrow, okay?